वेलकम बैक माय डियर स्टूडेंट्स, वेलकम बैक। यूर ऑल वेलकम। स्वागत है आप सभी का। वेरी हैप्पी गुड इवनिंग बेटा, वेरी वेरी हैप्पी गुड इवनिंग। पॉन्डर वाई मी श्यान मुखर्जी एंड एवरीवन। कंफर्म मी बेटा, एवरीवन ऑडियो वीडियो क्रिस्टल क्लियर टू ऑल ऑफ यू बेटा। एवरीवन एबल टू हियर मी, सी मी? कैन वी प्रोसीड? Just write CC in comment section beta. If you are all able to hear me, see me, then please write crystal clear. Okay? टुडे यू विल एंजॉय अलॉट बेटा। आज आपको बहुत मजा आने वाला है बेटा। ओके, एंड हिंदी एंड इंग्लिश बोथ लर्नर्स विल बी टोटली कंफर्टेबल इन टुडेज लेक्चर एज यू ऑलरेडी सीन इन माय पास्ट लेक्चर्स बेटा। जैसा कि पहले लेक्चर में भी आपने देखा है। सो हिंदी लर्नर्स बिल्कुल घबराइएगा नहीं, आपकी फीलिंग्स को भी समझते हुए ट्रांसलेशन बीच में इस तरीके से करते हैं कि आप भी फील कर पाओ। सो डोंट वरी अबाउट कि सर पूरा इंग्लिश में ले रहे हो तो वो फीलिंग थोड़ी सी घट जा रही है। डोंट वरी। ओके, क्रिस्टल क्लियर सर। वेलकम बेटा राकेश, सुष्मित नंडी एंड माय डियर स्टूडेंट्स। अगर आप शेयर कर सकते हो तो प्लीज ग्रुप्स में लेक्चर के लिंक को शेयर कर दो, बिकॉज दिस टाइम वी आर लाइव ऑन यूट्यूब, ताकि ज़्यादा से ज़्यादा बच्चे आज के लेक्चर का फ़ायदा उठा सके। ओके, and after completion of this lecture, maybe this lecture immediately private on YouTube, and then only available for paid members on our Gate Chemic Learning App. Okay, and my dear students, everyone who wants to join my crash come full course, PYQs course, or complete course for upcoming Gate examination, or after 1 year 2 year program, then don't worry, you can call me, WhatsApp me 9451707049 beta. Okay, English batch both are available. ओके, इंग्लिश लैंग्वेज के बैचेस भी अवेलेबल हैं, जिसमें हिंदी इंग्लिश का मिक्सचर फॉर्म में पढ़ाया जाता है, एंड प्योर इंग्लिश वाला भी अवेलेबल है। ओके, सो बोथ आर अवेलेबल। ओके, सो जस्ट कॉल मी और व्हाट्सएप में फॉर डिटेल्स और फॉर डेमो लेक्चर्स। So once again, my dear students, you are all welcome. Now we are in lecture number 2, mass transfer operation part 2, diffusion, continued in this lecture. As you all know, this side Gaurav Srivastav Sir from IITBHU, from Chemic Learning App, best chemical engineering app for GATE or any chemical engineering exam preparation. 14 plus years of teaching experience soon. अब ये आफ्टर एग्जामिनेशन 15 ईयर लिखने वाले हैं, जस्ट आफ्टर फ्यू मंथ. सो multiple I have multiple GATE top rank like GATE 2025, AIR-43, and many more top ranks I have along with my beautiful students. So without any delay, I am going to start today's lecture. But before that, just I want to ask you, beta, in lecture number 1, the topic that you had seen, revised everyone? No doubt, सबने revise कर लिया, and the numericals provided by me along with solution repracticed or not? Just tell me everyone, beta. आपने repractice किया था? Welcome बेटा मनोज, welcome बेटा मनोज. Just tell me बेटा. And Manoj, just WhatsApp me so that I can recognize which Manoj. क्योंकि बेटा बहुत सारा मनोज है ना, मनोज नाम के बहुत सारे बच्चे हैं. Because here your face is not visible on YouTube, your profile ID. Okay, everyone just tell me beta, all clear? Can we proceed with full of energy? Everyone just tell me, my dear students, can we proceed? सभी का कमेंट चाहिए बेटा, थोड़ी एनर्जी शो करेंगे क्योंकि लेक्चर थोड़ा लंबा जाने वाला है. ओके, बट बहुत सारे टॉपिक्स आप कवर करने वाले हो, मजा आ जाएगा. Okay, and I will tell you which formula you have to remember and which type of numerical they can ask, and I will also share numerical problems on each and every topic along with solution. Okay, yes sir. Okay, भानु प्रताप सिंह जी, सुष्मित नंदी जी, श्यान मुखर्जी, हाँ प्रैक्टिस किया था बट सम लेट बेटा. श्यान, कोशिश करिए कि कुछ भी मिस ना हो. प्रैक्टिस अभी थोड़ा लेक्चर में फ्रीक्वेंसी में थोड़ा सा अंतर, मतलब बीच में थोड़ा गैप मिल जा रहा है. बहुत जल्दी अभी आपका ये लेक्चर 1 2 3 4 5 6 बहुत तेजी से आपका एक दिन में 2 लेक्चर लगने वाला है. सो प्लीज थोड़ी स्पीड अपनी बढ़ाएं बेटा, कुछ भी पुराना छोड़े ना. डोंट एक्यूमुलेट. ओके, हाँ सर. ओके बेटा. ओके, इट्स मनोज ट्यूबिड. ओके बेटा, वेलकम बेटा मनोज ट्यूबिड. नाउ, so diffusion and numerical continue. Still we are in chapter number 1 in a complete mass transfer operation. If you want to see or you want to ask sir which 2 chapters are, or which chapters are most important, or you can say सबसे बड़ा largest which one, देन बेटा वन इज डिफ्यूजन एंड वन इज डिस्टिलेशन. ये दोनों बहुत लंबे लंबे हैं. एंड along after these two, all other chapters will take a very less time. So now we are going to continue this diffusion and numericals. Today I am going to start another topic, that is non-equimolar counter current diffusion. In a previous lecture, that was lecture number 1, you had seen two cases. One case you had seen in which equimolar counter current diffusion, in which you had seen Na is equals to minus Nb, equimolar counter current diffusion. And one more case you had seen, my dear students, that was B stagnant case. That was B stagnant case. Now, see, this is a totally different case, beta. This is not B stagnant, and this is also not equimolar. This is not equimolar. In equimolar, if 5 moles coming from this side to this side, then definitely at the same time 5 moles must come from right to left. That was equimolar, barabar mole ka counter current diffusion you had seen. But today it's non-equimolar counter current diffusion. First thing, I hope everyone know, if you want to vaporize any liquid, beta, then you must supply their respective latent heat of vaporization, that was lambda, in order to convert this liquid into vapor form. Vice versa, if you want to convert any vapor into liquid, then you have to remove their respective latent heat of condensation in order to convert them into liquid. Okay, where we are assuming that liquid and vapor both are saturated in nature. Like saturated liquid, that is liquid at its boiling point. Saturated vapor, that is vapor at its boiling point. I hope everyone knows these basics. सभी को ये बहुत ही आसान सा है कि लिक्विड को वेपर में बदलना है तो लेटेंट हीट देना पड़ेगा, वेपर से लिक्विड में आना है तो लेटेंट हीट को रिमूव करना पड़ेगा. ओके, एक पार्ट में आप हीट ऐड कर रहे हो, एक में रिमूव कर रहे हो. नाउ व्हेन यू आर गोइंग टू सी non-equimolar, then the most important case that you are going to see, that is totally related with latent heat of vaporization from distillation. In distillation chapter, you will see many methods for designing of a distillation column, or for the calculation of number of plates required for desired separation. आपको सेपरेशन के लिए कितना प्लेट चाहिए, ये सारी चीज़ें आपको कैलकुलेट करने को मिलेगी डिस्टिलेशन चैप्टर में. बहुत सारे मेथड्स पढ़ोगे. यू विल लर्न मेनी मेथड्स, few important, that was Maccabe-Thiele method, Ponson-Savoy method, Lewis-Sorel method. Out of these three, when you are going to see Maccabe-Thiele method, the main assumption of that method is that the latent heat of vaporization of liquid and vapor, or you can say both components, for binary mixture both components are same. That's why the molar flow rate of liquid or vapor along with complete column in respective sections like rectification and stripping not going to change. ये बदलता नहीं है, क्योंकि जितना लिक्विड कंडेंस करेगा, वेपराइज करेगा, उतना ही वेपर कंडेंस कर जाएगा. तो लिक्विड का फ्लो रेट और वेपर का फ्लो रेट में अंतर नहीं आता है. आप डिस्टिलेशन में ऐसा देखोगे. Okay, now here in short, because this is crash come full course, so to save time, just directly I want to tell you what is its conclusion, what equation you are going to use. Na equals to Nb, how it come? Actually the complete equation is Na lambda A equals to minus Cnb lambda B. This is complete equation, beta. If latent heat of evaporation same, then clearly you can see Na will be equals to minus Nb for this given case. Okay, and now it's equimolar counter current diffusion. But if lambda A is not equals to lambda B, if here in this case beta, if lambda A equals to lambda B, then this is the case of equimolar counter current diffusion. This is the case of equimolar counter current diffusion. But if, my dear students, lambda A is not equal to lambda B, then this is the case of non-equimolar counter current diffusion. So I think everyone understand what to do because once you got the relation between Na and Nb, then just you have to use your mother equation of diffusion in order to get that desired equation from which you are going to solve that given numerical. आपको केवल इतना पता चल जाए एन एन बी में क्या रिलेशन है, तो आप डिफ्यूजन के मदर इक्वेशन में उसे पुट करके आसानी से इक्वेशन को डेवलप कर लोगे, जिस इक्वेशन के द्वारा उस प्रॉब्लम को आपको सॉल्व करना है. So clearly, if they are going to ask any numerical from this topic, that will be 2 mark question. That will be 2 mark question. Okay, and clearly this is game changer type question because many students are now going to leave in examination hall. एग्जामिनेशन के समय वो नहीं कर पाएंगे क्योंकि नॉर्मल चीज़ बहुत सारे बच्चे प्रैक्टिस नहीं किए होते हैं ये सारे टॉपिक्स. और अगर आप कर दोगे तो डेफिनेटली आप दूसरे से अपने मार्क्स को बढ़ा पाओगे. So Na lambda equals to minus nb lambda b equation is very easy. Just you have to remember directly. Okay, like suppose one example, just a fundamental example. Just see here. Suppose in any problem they are giving lambda a at something like 100, lambda b they are giving like suppose 200, and both in some same unit. Let enter it in some same unit, both for same unit. Now you have to write this equation. Na lambda a equals to, wait, forget to switch on charger. Okay, and that equals to minus nb lambda b. Now just beta you have to put these datas here. So clearly it's 100 na, and that 100 na becomes equals to minus 200 nb beta. And after solving, clearly na will be equals to minus 2 nb. Okay, na will be equals to minus 2 nb. That means for every 1 mole of b transfer from right to left, 1b if transferred from right to left, then respective to this 2a is going to transport it from left to right. So clearly it is not equimolar. But sir, how to solve numerical? You told me about mother equation. Yes, my dear students, I told you about mother equation. You all remember what was the mother equation of diffusion? I told you in my previous lectures here, and I hope everyone remember this equation beta. हमें उम्मीद है सभी को इक्वेशन रिमेंबर होगा. And that was n a by a equals to n ya or nx. So n is na plus nb. So na plus nb into ya by a and minus dab into dca by dz. Now just you have to put here na value or nb value. After putting this nb value, you have to solve this beautiful differential equation. Like in that given case, nb will be na by 2. You have to put nb equals to minus 0.5 na for previous example. And just solve it, you will get your desired equation. Okay, so I hope it everyone crystal clear. Minus sign are going to use in numerical, or minus is just no beta Rakesh. Here this minus you are going to put here. As I told you, here you have to put na minus 0.5 na. Like here, after solving, it will come na minus 0.5 na, then it will be 0.5 na. So यहाँ पे माइनस एक सिंबल नहीं है, वो यूज भी करना है आपको. यू हैव टू यूज इन न्यूमेरिकल. बट इन एग्जामिनेशन इफ दे आर आस्किंग अबाउट द वैल्यू ऑफ एन बी, सो एन ए निकालने के बाद द वैल्यू आफ्टर, if they are asking about nb and after calculation of na, if you are going to put that nb value, then in examination don't put there in your answer key that minus sign, because clearly they will mention, just tell the value of the flux or the rate of mass transfer of b. So clearly they mentioned, they are not asking about their respective direction in these type of numerical. So please don't use minus sign while writing answer in examination, but while deriving you have to use that minus sign here. Okay, beta Rakesh, is it crystal clear, beta Rakesh? So first topic, I hope everyone crystal clear about non-equimolar countercurrent diffusion. And see one beautiful problem also here, problem number 8. And a very beautiful problem. I'm not going to solve here because this is a crash come full course. So I will give you many numericals, but discuss only most important here in life. Okay, and remaining you have to solve. After seeing this beautiful solution is also here, see, in this all things are given on in this two-step question, because here you have to check unit 2 of lambda a lambda b. So after converting to respective units, just see, you have to put, this is your relation. After getting this relation, just you have to put here, see here. Okay, and now you have to derive it, and after addition you will get your final expression. Just put values and you will get answer. In examination maybe they can give you some type of data, so that you will get this something like nb equals to 0.1 na or 0.5 na, these type of data. So calculation will be a little bit less. And why here I, in this problem I changed the unit of lambda a lambda b, because maybe in examination they can just ask this relation, वो केवल इतना relation भी पूछ सकते हैं, and in that case this will be your final answer. They can ask you which one of the following shows the right value of nb in terms of na, so this is the right answer. So in that case they are not going to provide you lambda a lambda b directly, because if they are going to provide directly, this is just one line question and that will be 1 mark question. But if the unit is not consistent with this na, you have to convert unit, you have to convert unit. Okay, so I hope everyone crystal clear, and this you have to re-practice again, my dear students. Okay, now next topic is variable area diffusion with numericals. Okay, sir can answer your just minus just notation symbol minus crystal clear sir. Okay beta, very good, fantastic, mind blowing, super. So beta, can we proceed towards next topic, that is variable area diffusion and numericals? सभी को क्लियर है, हम आगे बढ़ सकते हैं. So the thing only you learn that you have to remember is lambda a lambda b, how you are going to use along with n in counter current diffusion. So n a lambda equals to minus n b lambda b. That's very easy to remember. Very easy to remember. Okay, चलो बहुत अच्छा. So variable area diffusion derivation of these are very lengthier one, and I already derived these all many cases in my detailed course. उसमें सब derive कराया. But here I am going to give you direct equation, and also I will tell you how to remember them. You will remember them in less than 1 minute or less than 30 seconds. सारे जितने इंपॉर्टेंट केसेस हैं, लाइक दिस केस एंड मे बी वन मोर केस दे कैन गिव यू, लाइक हियर इट्स इक्विलैटरल ट्रायंगल ट्रैपर्ड ट्यूब, हियर this type of tapered tube, or maybe tube cross section is available like square, हो सकता है ये स्क्वायर फॉर्म में हो, मे बी दैट इज इन स्क्वायर फॉर्म, like a1 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 side, and this is a2 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 and a2 side. Okay, so if diffusion is also happening in this case, how to write respective final equation, बहुत ही आसान है, it's very easy. So just see beta, variable area diffusion, important cases that you have to remember. First, accumular counter current diffusion through variable area, and second, B stagnant case, that is unimolecular diffusion through variable area. Hence see conclusion, that's it. So how to remember, don't worry. So first, my dear students, see this case. If radius of this side is r1 and radius of this side is r2, you know the equation was for accumular counter current diffusion, Na by A equals to DAB by RTZ, and then PA1 minus PA2. ये तो इक्वेशन होता था यार. Now because area, this is cross section area, area of diffusion. So what area you are going to choose here? Because area is variable one, so don't worry. In that case, the rate of mass transfer will be same at each and every cross section, but flux is not same beta. Flux same nahi hoga. Okay, that's why you can't write this A. If you are going to put A at any respective place A, then that will give you that respective place flux. अगर आप जिस जगह का आप एरिया पुट करोगे उसी जगह का आपको फ्लक्स भी मिलेगा. So just very easy, you know this is a circle. If you are going to see from this, and the area is pi r square, so just see pi r1 r2 in place of this A. pi r1 r2 will come, pi r square. So which r? So r1 r2, this will come after complete derivation. So it's very easy to remember. Similarly, for B stagnant case, you know dAB by RT is at P by PBLM PA1 minus PA2. So what you are going to put in place of a pi r1 r2? So what to do in case of equilateral triangle tapered section? For equilateral beta, for equilateral, what is the value of this area? ये area कैसे निकालते हो? It's √3/4 a square for this equilateral triangle where this is a a. But what to do if this side a1 a1 a1, this side a2 a2 a2? So see, again the complete formula that you are seeing here is same. Just in place of this a, you are not writing here, you are putting this a, √3/4. Instead of a square, you are putting a1 a2. So very easy to remember now. Already derived these all cases in my detailed course beta, and derivation is little bit lengthier, but see, no need to derive it, no need to derive it. After seeing this conclusion, my dear students, easily you can remember them. I hope everyone crystal clear, आसान लग रहा होगा ये. Like here it's already you can see be stagnant case, just you are going to put here. Okay, so bolo sabhi ko clear hai kya? If clear, then I am giving you one more case, then you have to write their respective equation. After writing, just write done and then compare with me. अगर ये क्लियर है तो एक केस आपको दें और फिर आप उसका भी इक्विमोलर और बी स्टेगनेंट का लिख के दिखाओ कंप्लीट इक्वेशन क्या होगा रेट ऑफ मास फ्लो रेट का. क्रिस्टल क्लियर सुष्मित इंडियन एवरीवन? ओके बेटा, फटाफट देखेंगे, फटाफट देखेंगे. सो नाउ आई एम गोइंग टू गिव यू वन मोर केस, केस नंबर 3. I am giving you case number 3, and now you have to write beta, you have to write, you have to write. Okay, so this time the case is the section, the cross section is available in some, you can see it's अरे यार थोड़ा सा सुंदर बनाने का. See, for a square tapered cross section, or for a square tapered case. अरे यार wait, okay, and here in this case beta, this is a1, this is a1, this is a1, this is a1, this is a2, this is a2, this is a2, this is a2. Okay, and suppose this is the mole transfer rate, you have to see from this side to this side. Okay, no problem. Now I want two equations here beta, आपको दो इक्वेशन इसके लिए लिखना है. फर्स्ट, for equimolar, for equimolar counter current case, and for B stagnant case, B stagnant case. Now please write and write done in comment section बेटा. ये इक्वेशन लिखेंगे और लिख के दोनों के लिए जो फ्लो रेट, मास फ्लो रेट का फॉर्मूला होता है एन ए, फॉर्मूला फॉर एन ए, just write here, and after writing this formula, just write done in comment section and then compare with my formula. Come on everyone. Sir, like a sphericity, do they merge different shape and ask to make relation? Sphericity, but here sphericity will not come in mass transfer operation questions. That is a topic of mechanical operation solid handling. Rakesh, if any doubt in that topic, and you can ask me on WhatsApp beta. Done Divyansh? Very good. Everyone just tell me done. सभी का हो गया क्या? Everyone done? Okay. So the right answer is A1, A2, DAB by RTZ, PA1 minus PA2, and here A1, A2, DAB by RTZ, P by PBLM, PA1 minus PA2. इज इट सेम? हमने क्या सेम लिखा था? देखा कितना आसान है। लोग कहते हैं अरे ये तो केस नहीं आता, ऐसा नहीं बेटा, सब पूछता पूछा हुआ भी सब कुछ आता है। वेरी वेरी इजी टू रिमेंबर। सी हाउ इजी इट इज। जस्ट यू नो हाउ टू calculate cross section, that respective cross section area. Like here area of a square is a square, side square. Same ना? Just tell me same, then please write same in comment section बेटा। अगर आपका भी same था तो please everyone write same in comment section बेटा। Same to same? You all got same? Just tell me my dear students, same to same. Don't waste time. Tell me everyone. Rakesh sir, I am talking about like in sphericity, they merge two different shapes. So in mass transfer, do they merge different shape to write equimolar or V stagnant? I don't think so, beta, that they can merge because derivation is very very large. Wait. I am showing you their respective derivations here. आपको दिखाते हैं derivation. रुक जाओ. See how large these derivations are. So clearly they can't ask यार. आप नहीं पूछे जाएंगे. वो आपको पूछा ही नहीं जाएगा. बहुत लंबे derivation होंगे. And in 3 hour question paper I don't think so. I can tell you it's 0% chance. और अगर पूछेगा तो कोई गधा ही उसे सॉल्व करेगा। ओके, बिकॉज दैट विल टेक approximately 20 to 30 minutes maybe, or minimum yeah more than 10 minutes, 10 to 15 minutes at least. Wait, I'm showing you the respective derivations from my main file. Just wait. From my detailed course I'm showing you these all topics. Just wait. See how large these derivations are. How large these derivations are. See. Wait, processing is going on. Very large file. Just wait, it's still uploading. Scanning, actually it's scanning. Are you all able to see? क्या आप देख पा रहे हो? हाँ, देख पा रहे हो। देखो, the first case, how long it is. Derivation started from here. Now here. No, here you got the final expression here. Okay, numerical. Then see, B stagnant case. Again see how large the derivation is. So derivation is not a smaller one. So if very both side different bodies are present, then you can't be able to derive it in less time or the time provided in gate examination. आप नहीं कर पाओगे. So not they are not going to ask. वो नहीं पूछ सकते. So don't worry बेटा. ओके नहीं बेटा, ये फ्लक्स का कहाँ है बेटा? इट्स मास ट्रांसफर रेट माय डियर स्टूडेंट्स. ये मास ट्रांसफर रेट का है बेटा. In these type of cases, if they are going to ask flux, then they can ask, tell me what is the value of flux at this point where radiuses are. So for that case, after calculating this NA, write NA by pi r square. This is the value of flux at this place, because flux is not same at every cross section. Flux is different. मास फ्लो रेट इज सेम बिकॉज स्टडी स्टेट मॉलिक्यूलर डिफ्यूजन. मास फ्लो रेट तो हर क्रॉस सेक्शन पे सेम ही होगा. 50 चला है तो यहाँ भी 50 ही रहेगा, यहाँ 50 ही रहेगा. लेकिन फ्लक्स सेम नहीं रहेगा, क्योंकि फ्लक्स पर यूनिट एरिया लेते हो. तो जहाँ का एरिया कम है ज़्यादा है, जहाँ एरिया कम है यहाँ पे आपका फ्लक्स ज़्यादा आएगा, यहाँ पे फ्लक्स आपका कम आएगा. बिकॉज NA by A is flux बेटा. NA by A is flux. If area more for same mass flow rate, flux will be less. If area less, then for same mass flow rate NA, flux will be more. So if they are asking, then in that case first you have to calculate this NA, then just divide that NA from that cross section area. प्रांजल बेटा, क्या ये क्लियर है? आपको उस क्रॉस सेक्शन के एरिया, किसी भी रेस्पेक्टिव केस के उस क्रॉस सेक्शन के एरिया से जस्ट आपको डिवाइड करना होगा. and that will be the value of flux at that respective position. बोलो ये clear है क्या? Can we proceed? Can we proceed बेटा? Is it crystal clear? चलो बहुत अच्छा, वेरी गुड, फैंटास्टिक, माइंड ब्लोइंग, सुपर, बहुत अच्छी बात है. जस्ट अ वेट. नाउ सो द थिंग्स यू हैव टू रिमेंबर ओनली दिस. केवल आपको ये याद रखना है that how to calculate area of these respective important case. Many type of cross sections possible, but these three are standard that can be asked. They're not going to ask any other case, so don't worry. You are undergraduate students and they are going to give you paper to solve within 3 hours. Okay, clear beta Divyansh and everyone? So just you need to remember these respective shapes area. First one, I think approximately 100% student know. Second one also, only I think few students don't know about it or may forget this. So only you have to remember this shape, root 3 by 4 a square, and very very easy. Crystal clear? चलो बहुत अच्छी बात है. Fantastic, mind blowing, super, super भाई, super. So again see, beautiful numerical based upon that. See, all data are given, only the different is carbon dioxide is diffusing at a steady state through nitrogen by equimolar counter current diffusion in a conduct 1 meter long. Total pressure this, partial pressure this. This line, see, the cross section of conduct is in the shape of cylindrical of radius disc at the left and tapering uniformly. In every case, just you have to solve uniformly. If not uniform, you can't solve by pen. Software needed for that type of calculation. Okay, like suppose they are giving like this shape. I said, this type of section. You can't calculate this. Okay, you need some software. You need some software for calculation. So they can't ask. So tapering uniformly to a radius of this. All things are given. All things are given. Just extract data, and now you know the formula. Instead of a, you are going to put this. See, just one line calculation, how small this numerical is. Now again in homework you have to solve this. You have to solve this so that you can feel, or you can feel more and more confident. Okay, now in same problem, if they are asking, tell me the flux at r is equal to 0.04 meter, then already calculated in. This is extra part of this question number 9. And now just see that place area you are going to divide from that flux. You will get this as your flux at that point. So I hope everyone crystal clear beta. So again you have to solve this beta. एक बार फिर से आपको ये solve करना होगा in homework. Okay, clear? लग जाएगा ना? Just tell me, everyone able to solve this numerical ना? Very very easy numerical ना? Just tell me yes sir in comment section, everyone beta. Don't kill time, immediately reply me beta. Immediately reply me yes sir. All clear to all of you beta? Yes sir, fantastic, fantastic, mind blowing, super. That means we can proceed towards next question. See, one more beautiful problem. This is relating equilateral triangle. Again very very easy numerical. You have to solve this also. Okay, solution also given by me, so that if any doubt you can see this solution. Okay, and here again extra part, if they are asking flux at any given point, what to do. And this is a 2023 get 2 mark question, very easy question. So here they are just asking unimolecular to equimolar diffusion, what is the ratio. So very very easy to solve, one line numerical. So please solve it. Answer will be 1.178. Okay, and again 1994 one question here I am giving you, and this is very easy question relating equimolar counter current diffusion. So यहाँ भी solution दे दिया है ताकि आप आसानी से practice कर सको. If answer is not unable to see here, then wait, answer I am writing here 3.898 into 10 raised to power minus 5 in the respective unit. This will be your answer. So again you have to practice these all, because this is crash come full course, so here I can't solve these numericals live. That's why यहाँ आपके लिए हमने सब सेट कर दिया है, जिससे कम समय में लेक्चर भी कंप्लीट हो जाए, और आप वैसे भी ये प्रैक्टिस करते ही हो, कोई भी न्यूमेरिकल जब लाइव में लगाते भी हैं, सो आप इसे वापस से रीप्रैक्टिस कर लो. यू हैव टू रीप्रैक्टिस these all numericals that I am going to provide you. And after these all numericals, no need to see even a single numerical from any book or anywhere. कहीं भी आपको देखने का जरूरत नहीं है. जितना इसमें लगवाया कंप्लीट मास ट्रांसफर के लिए, दैट्स मोर देन सफिशिएंट, मोर देन सफिशिएंट. उसके अलावा सिंगल न्यूमेरिकल कहीं से देखने की जरूरत नहीं है. It's my open promise to you, open challenge to all of you. So again this homework. Now next topic, pseudo diffusion and numericals. So यहाँ तक सभी को clear? Can we proceed बेटा towards this topic, pseudo diffusion and numericals? लास्ट टॉपिक इज क्रिस्टल क्लियर, सभी को क्लियर है क्या? क्या हम आगे बढ़ सकते हैं? कंफर्म मी एवरीवन, कैन बी प्रोसीड? आसान लग रहा है ना सभी को? हाउ इजी? वेरी वेरी इजी ना? ओके. सूडो डिफ्यूजन, व्हाट इज द मीनिंग ऑफ सूडो इन हिंदी? आभासी. So pseudo means, pseudo diffusion means abhasi diffusion. That means it is not about abhasi diffusion, it is abhasi steady state diffusion, pseudo steady state diffusion. That means actually that is not happening in a steady state manner, but it looks like a steady state because the process is very very slow. बहुत स्लो हो रहा है, वो इतना स्लो हो रहा है कि किसी एक छोटे टाइम इंटरवल में हमको देखकर वो स्टडी स्टेट जैसा ही लग रहा है. If we are going to check in a very small time interval, then it looks like a steady state. Like if the value is 2.333334, then after some time it looks like 2.333333. Very very less change. Suppose this change I am checking after something like 10 minutes or 5 minutes or 1 minute. So it looks like a steady state, but in actual it is not the case of a steady state. Okay, so because the process is very very slow, so we can deal it like a steady state. That is pseudo steady state diffusion. That is pseudo steady state diffusion. ऐसे ही केसेस को स्टडी स्टेट डिफ्यूजन, सूडो स्टडी स्टेट डिफ्यूजन कहते हैं. लाइक सपोज this is one tube and some liquid you are going to fill here, some liquid you are going to fill here. Okay, initially the level is this. Okay, suppose this is the initial level at some time t1 equals to 0. After very large time, after very very large time, like t2 equals to 2 hour, the difference in height is just suppose 0.1 mm. Very very large time, change in height is very very small, so we can deal this case like a steady state. हम steady state के formulas को यहाँ भी apply कर सकते हैं. So this is the case of pseudo steady state diffusion. Now, what type of numericals they can ask you? Directly I am coming to that topic. सीधे सीधे मुद्दे पे आते हैं हम लोग. Okay, because this is crash come full course, so we can't kill a single second here यार. कम से कम समय में सब कुछ कंप्लीट भी करना है और पूरी फीलिंग के साथ. सो आई होप हम समझा सके हैं आपको इस बहुत ही छोटे से टाइम इंटरवल में कि ये क्या है सूडो स्टडी स्टेट डिफ्यूजन. सो जस्ट टेल मी इफ एवरीवन अंडरस्टैंड व्हाट इज सूडो स्टडी स्टेट डिफ्यूजन, देन प्लीज टेल मी यस सर इन कमेंट सेक्शन. फटाफट सभी लोग यस सर लिख दोगे. एवरीवन प्लीज राइट यस सर इन कमेंट सेक्शन. एवरीवन प्लीज राइट यस सर इन कमेंट सेक्शन. Yes, sir. Okay. So see, this is the case that you have to see. Pseudo steady state diffusion through a stagnant film. Pseudo steady state diffusion through a stagnant film. In a general mass transfer operation. See, आराम से पढ़ते हैं इसे. In general mass transfer operations, one of the boundaries, वही जो हमने कहा ना ऊपर से लेवल गिर रहा है, that is one of the boundaries may move with time. Like here, this boundary is moving, this boundary is moving with time. Okay, maybe this is the case. If the length of the diffusion path, what is the diffusion path here my dear students? what is the diffusion path in this case? Previously, this is the path of diffusion, because here the main stream is coming in which this liquid is going to diffuse. But after some time, this is the diffusion path. This is the diffusion path. That is Z in your previous formulas. Okay. So if the length of the diffusion path changes a small amount over a long period of time, 2 hours, just 0.1 mm. Oh my god, very, very slow. A pseudo steady state diffusion model may be used. When this condition exists, the equation of steady state diffusion through stagnant gas can be used to find the flux, as I told you earlier. कि ऐसे केसेस में आप स्टडी स्टेट डिफ्यूजन वाला फॉर्मूला इस्तेमाल कर सकते हो. Same thing here, same diagram here given by me. Okay, as time increases, Z increases. See, Z, Z increases. This is the previous Z and this is the new Z beta. This is the new Z. So Z increases. Na by A decreases. Na by A decreases. Flux decreases. How? How flux decreases? See, see. Because in flux equation Z is present in denominator, and if this is going to increase, clearly the flux is going to decrease. If this is going to increase, because this is present in denominator, because this is present in denominator, so if it is going to increase, this is going to decrease. If it is going to increase, this is going to decrease. I hope everyone able to understand what I want to tell you, beta. Okay. So Na by A is going to decrease. Now, how they can ask problem relating this topic? They can ask you one thing, that in order to decrease the level in this from Z1 to something like Z2, how much time required? This is the problem number 1. And in second case, they will provide you time and that length, and they will ask you what is the value of diffusivity of A in this B. What is the diffusivity of this A in this B? So two types of problem they can ask you in examination. GATE examination. They can ask you two types of problem. Okay, like time t barabar 0, the length of diffusion is ZT naught. At some time t, it's ZT. Okay, so they will provide these data and they will ask you what is the diffusivity of A in B. So two types of numericals they can make in examination. बोलो ये सभी को क्लियर है क्या? एक बार फिर से सब लोग क्रिस्टल क्लियर लिख दो तो. Everyone please write crystal clear in comment section beta. If everyone understand what topic I am discussing here यार. बोलो सभी को क्लियर है क्या? Everyone crystal clear? Okay, now in this type of problem beta, one more thing you must know, that every time at the surface saturation condition is present. Saturation at the surface, and here just at the top of this tube the value of Pa will be 0. Why? As soon as this A is coming towards this point, immediately swept away by this B. जैसे ही A आ रहा है B उसको उड़ा के लेता जा रहा है और नया B फिर वहां जा रहा है. सो यहाँ पे हम लोग मान लेते हैं कि A है ही नहीं. सो ऐसे केसेस में इन दिस टाइप ऑफ केसेस, सी एवरी टाइम Pa is 0 at this point, and at this bottom boundary Pa will be Pa set at given temperature at which this A is available, at which temperature this A volatile liquid A is available. Okay, so बोलो सभी को क्लियर है क्या? Crystal clear sir जी. Okay, so directly I am coming that equation. Wait, complete derivation no need to see my dear students, but here wait, here actually the final equation is very, very large, so I want to show you some basic here. कुछ बेसिक आपको यहाँ दिखाना चाहते हैं. ये सब छोड़ो, ये सब देख के हिल जाओगे यार, ये सब देख के हिल जाओगे. इधर देखो, इधर देखो, इधर देखो. Now in this case how to write Na by A? What is Na by A beta? Na by A is molar flow rate of A per unit area. How to write it? इसको कैसे लिखेंगे? हाउ टू राइट इट यार? सी सी if you want to write this Na, then Na will be, sorry, here second is also present, Na will be kilomole per second. Wait, so Na will be kilomole per second. So if you are going to use here molar density multiplied with rate of change of volume within the tank or within this capillary tube, this is meter cube per second and this is kilomole per meter cube. See, you will get ना. अरे भाई, इसमें जिस रेट से लिक्विड खत्म होगी उसी रेट से तो ये बाहर को डिफ्यूज हो रही होगी ना यार, बोलो. जिस रेट से लिक्विड अंदर को खत्म हो रही होगी उसी रेट से तो डिफ्यूज करेगी ना. इसका डायरेक्ट फॉर्मूला आपको याद नहीं करना, ये फॉर्मूला बड़ा है इसलिए इसका डेरिवेशन आपको देखना पड़ेगा यार. सो आई एम गोइंग टू डिस्कस द डेरिवेशन दैट इज इंपॉर्टेंट फॉर यू. यू कांट रिमेंबर दिस लार्ज फॉर्मूला ना, ना नहीं याद कर पाओगे. ये आपको रिमेंबर नहीं करना है. दिस you have to derive it. You have to derive it in examination hall. Derivation is just one line derivation. So please tell me, क्या ये सभी को clear है क्या? Everyone crystal clear about this equation? The rate at which A is going to amount decrease rate in that tube must equal to the rate of diffusion in B. अरे जिस रेट से ये घटेगा उतना ही तो बाहर जा रहा होगा. लॉ ऑफ कंजर्वेशन ऑफ मास, ये वहां पैदा थोड़ी ना हो रहा है यार. इज नॉट अपियरिंग हियर. Just tell me everyone, is it crystal clear here? Is it crystal clear? Sir, can you repeat once more? Susmit Nandi, beta, I am telling you कि आपके इस अंदर कैपिलरी ट्यूब से ए जिस रेट से खत्म होगा उसी रेट से तो ऊपर में बढ़ेगा ना, जो उसी रेट से डिफ्यूज हो रहा होगा. द रेट ऑफ डिक्रीज ऑफ अमाउंट ऑफ ए in the capillary tube must become equal to the rate of diffusion of A to the B. अरे जितना अंदर, जितना भागा उतना अंदर कम हुआ होगा ना, या जितना कम हुआ होगा उतना ही तो भागा होगा रे भाई. बोलो सभी को क्लियर है? इज इट क्रिस्टल क्लियर? इफ 1 kilomole in 1 second decrease in that capillary or in that tube, then definitely that means in that 1 second 1 kilomole diffuses. अगर वहां नहीं तो डिफ्यूज ही तो हो गया यार. Crystal clear? Okay, very good. So if this is clear, then this molar can be written as mass density of A to molecular weight of A. This is mass density, kilogram per meter cube, and divided by this molecular weight. Divided by this molecular weight. What is the formula? Unit of conversion unit of molecular weight, kilogram per kilomole. After cutting, you will get kilomole per meter cube. You will get kilomole per meter cube. And this V, how much volume? So this is the volume na yaar. This is the rate of decrease in volume in dt time. In dt time. So volume can be written as if Z, if total height decreases Z in dt time, if height decreases in this dz in this dt time, from this cross section area A, suppose area A. So A, we can write V as dV as A into dz. Why I'm writing A outside this differential? Because the initial formula is AZ. But because here this is not tapered one, ये ऐसे नहीं है, हाँ? And they can't give you this type of case because this will be little bit lengthier in derivation. Okay, ये थोड़ा lengthier हो जाएगा इसलिए वो ऐसा नहीं देंगे. Okay, थोड़ा कैलकुलेशन में ज़्यादा टाइम लगेगा. Possible, all things are possible. And even you can solve with the help of just pen, no need of any software. So you can put now in place of this V, dV, this A into dz, that in dt time this amount of A is, this amount or this volume of A is disappeared from this tube. बोलो सभी को clear है क्या? Is it crystal clear to all of you beta? So the same thing here you have to remember. See the amount of A, rho AL by MA. AL means in liquid side density. Liquid में कम हो रहा है ना, so don't write vapor density of A. So rho AL by MA d by dz ZA. So here rho ALMA, and this A you can write here. And now everyone know what is the formula for Na by A for this given case. Clearly this is B stagnant case. So you can use one of the B stagnant formula. For a given period, at any instant, the molar flux can be written as this B stagnant phase. So just you are putting Na by A here and this here. First order linear differential equation. When time is 0, level was Zt naught. At some time t, level was Zt. Just integrate it, you will get this equation. ओके इस डेरिवेशन को एक बार फिर से आप प्रैक्टिस भी कर लेना बेटा. सो आई होप एवरीवन क्रिस्टल क्लियर. हाउ टू डिराइव इट बेटा बोलो, ये क्या है सभी को क्लियर है कि ये कैसे डिराइव किया हमने? एवरीवन क्रिस्टल क्लियर. सो हियर नो नीड टू रिमेंबर. In exam you have to derive it. If they are asking, then you have to invest approximately 90 seconds for this derivation, then 2 minutes to solve this numerical. That means 3.5 minute numerical. Okay, is it clear to all of you? बोलो सभी को clear है क्या ये case? And now if they are asking diffusivity, just this here and this t here. See, very easy, very easy. So two types of numericals they can make you, and clearly they are going to make 2 mark problem. ऐसे problems 2 mark के आते हैं. Okay, clear? चलो, so again see one beautiful numerical based upon previous topic that you had seen, and here given that initially level was 0.03 meter and after some time it is 0.08 meter. Then what is the value of diffusivity? So all things are given in this problem. Just you have to solve it. So just put in this formula, then you will get your answer beta. Okay, C is not there, so you can write C as P by RT, and don't forget to check units. So ये भी homework है. Numericals I can't solve here. So just आपको एक concise form में numericals को बता सकते हैं और आपको भी मेहनत करनी होगी. Okay, you have to re-practice numericals. But it can ask in gate examination. Okay, ये 2 नंबर के क्वेश्चन में पूछा जा सकता है, because problem is very easy and relating pseudo, and pseudo already asked in past PYQs. Okay beta, is it clear to all of you? Is it crystal clear? Can we proceed? Can we proceed? ये लोगो क्यों गायब हो गया रे भाई? बोलो आगे बढ़ा जाए. Can we proceed beta? Done? Crystal clear. Chalo, very good. So next topic is very important. Already asked many PYQs from this topic, that is diffusion into an infinite stagnant medium. Okay, and here also the derivation is very lengthier one. So here the good thing that you have to remember final formula and no need to remember complete formula. Okay, Rakesh, density in mother equation that was density of liquid A. क्योंकि लिक्विड ए की कमी को आप लिख रहे हो, टैंक में जो लेवल घट रहा है वो लिक्विड लेवल इज डिक्रीजिंग इन लिक्विड फॉर्म बेटा. So that is the density of liquid A. See here in this problem, clearly it is mentioned here. See density of liquid toluene, that is rho Al. Okay, clear beta? Clear beta Rakesh? Okay, very good. Whenever they are asking these type of numericals, they will provide you some type of solid like a naphthalene ball that is directly sublimation, sublime in some gaseous medium, or maybe some droplet of water like baris ki boonde, rainwater, and that rainwater is going to evaporate. Then what is the value of rate of mass transfer at any given time t? This is the case, that is diffusion into an infinite medium. बोलो start किया जाए क्या ये? Please everyone tell me. Everyone tell me. Just wait here. Logo is not coming, so just I have to add logo one more time. Just wait. Just tell me, is it crystal clear? Is it crystal clear to all of you, beta? I hope logo successfully added. Okay, very good. So already asked many PYQs you can see like a gate 2022. So diffusion into an infinite stagnant medium. In this topic, we will discuss problems involving diffusion from a spherical particle into an infinite body of stagnant gas. हम इस टॉपिक में किसी स्पेरिकल पार्टिकल को लेंगे जो किसी एक स्टैग्नेंट गैस, रुका हुआ गैस है, उसमें सबलाइम हो रहा है. Evaporation of a spherical droplet or sublimation of a naphthalene ball. Like this. This is the ball. This is the ball. This is the ball. Okay. Now, just see here. The flux Na cap is not constant. If you are checking here, what is the value of flux at this r radial direction? What is the value of flux here? What is the value of flux here? Because whenever area is changing, see this time this area, this time this area. When area is changing, flux will change even for steady state mass transfer. So two cases you have to see. One case when you are doubling or tripling or changing the size of particle, spherical particle, what is the effect on respective mass transfer rate? And the second, if this will take complete time for some limitation t1 time, then this size take t2. What is the value of t2 if t1 given and the size relation is given? So two types of cases here, and directly you have to see, no need to see their respective derivation. And this is a complete formula after derivation, and not important at all. This complete formula is not important. So if you are seeing this lecture right now, like just nearby 2 3 months left for gate examination, so please just ignore it, but don't ignore this, don't ignore it. This is very important, very very important. This is very very important. Okay. Now if you want to see, just see gate 2022 already asked one beautiful problem relating this. If you know only W is proportional to RS, 1 mark for you, beta. Okay, 1 mark for you. So no need to see this complete, and please don't remember this. इसे याद मत करना. And what is W? W is our Na, that Na we are giving in previous. That Na here I am writing like W. So ये याद मत करना. याद क्या करना? केवल ये. You have to remember. You have to remember this, beta. You have to remember this directly. Remember directly this one. आपको सीधा सीधा ये याद करना है. इसका कोई भी डेरिवेशन देखने का रिक्वायरमेंट नहीं है. Remember it. Okay. And this I am not recommending to remember. इसे भूल जाओ, इसे भूल जाओ, इसे भूल जाओ, इसे भूल जाओ. रेयर केसेस होंगे जिसमें ये कंप्लीट फॉर्मूला पे न्यूमेरिकल आएगा. In any gate examination, the chances is very very less, just like 0.1 or 1%. And for upcoming gate examination, I am not recommending to remember the formula number 1, gate formula 1. Just you have to remember concise form. Clear to all of you? One more time please write CC in comment section. बेटा सभी लोग लिखोगे, एक बार फिर से सभी लोग लिखोगे. क्रिस्टल क्लियर? Everyone just tell me, beta. Clear? Okay. Now the second question that I told you. Here the problem, like see universal question, that is problem number 14, beta. If radius of a spherical ball is 10 centimeter, then the rate of evaporation is 100 mole per second. If the radius is half, what is the new value of rate of evaporation? No need to worry. W is proportional to RS. RS means radius up to this surface तक का radius. So W2 by W1, RS2 by RS1. W1 RS1 RS2 given, just put here, you will get W2 as 50 mole per second. 50 mole per second for this case. I hope everyone crystal clear बेटा. I hope सभी बच्चा लोग को ये clear होगा. Okay, done. Now second case I told you, if this ball for complete sublimation took T1 time, this T1 time given, then they can ask you for 5 centimeter ball, what is the time for complete sublimation? Complete sublimation time they can ask you. Okay, it is possible to calculate time for any given sublimation value like R1 to R2 तक पहुंचने के लिए कितना वैल्यू चाहिए, कितना समय लगेगा. बट अगेन दैट इज लिटिल बिट रेयर थिंग दैट कैन बी आस्क्ड. थोड़ा सा अंदर हो जाएगा, ज़्यादा डेप्थ तो उतना वो नहीं पूछते एग्जाम में. गेट एग्जामिनेशन में आपको बस जानते हैं कि पढ़े हो कि नहीं पढ़े हो आप. जस्ट दे वांट टू चेक योर फंडामेंटल दैट you know this topic or not. If you know, then they can give you only proportional type of numerical. This I'm telling you based upon my approximately 15-year experience. Many top ranks I got along with my students, under 100, under 50, many ranks nearby 100. So based upon my experience beta, and also after examining more than 35 plus years of question paper, I'm telling this thing to you. That's why I'm not recommending to use to remember this complete formula. Like here also, time required for complete sublimation. See, this is the beautiful formula, and again 0.1% chance. So please don't remember. Not important. Not important. Complete formula, not important. And even the student, those you are seeing live right now, please don't write even this formula in your notebook. अगर ये lecture आप तब देखते हो if examination is still 10 month or 9 month still left, then you can write in your notebook, but still no need to remember. See, little bit complex type of equation, so no need to remember, no need to remember these equations. You have to remember only the thing for complete evaporation case, this proportionality thing. RS naught means initial value. Initial value. If you want to see its derivation, wait, I'm showing you. Derivation is very very large यार, बहुत लंबा है जो आपके काम का नहीं है. In complete course, in detailed course, I solve these all derivations too. Derivations भी आपको कराते हुए चलते हैं detailed course में, जो 1 year का होता है या लंबा होता है, 7 month 8 month if you have at least 9 month. Like here, see derivation, how large the derivation is. See this is the derivation. See derivation, see derivation. So you can't do this derivation in examination. And again, see, for second case, this is the derivation, this is the complete formula. If you want to get from some RS not to some RS, how much time required is still little bit large. अभी ये थोड़ा लंबा लग रहा है, डेरिवेशन थोड़ा लंबा, ये नहीं देखना है. No need to see this, no need to see this. Okay, you have to see just proportionality thing. आपको केवल proportionality वाला देखना है. Everything will remain same and they will ask you. Okay, and if any respective radius given, it can also be asked, because just you have to write in second case, in first case radius 1 radius 2, and then for second case radius 1 and radius 2. So things are still very very easy. But only the problem that can ask proportionality type problem बेटा, वो क्या पूछ सकते हैं, वो केवल और केवल पूछ सकते हैं proportionality type problem. Okay, yeah, वो केवल proportionality type पूछ सकते हैं. So that's why I told you these things. Okay, for TC, if you want to write TC, so TC is proportional to RS naught square minus RS dash square. अगर किसी RS naught से आपको कहता है RS dash तक पहुंचने के लिए टाइम क्या चाहिए उसमें, तो इसकी जगह आपका ये आ जाएगा. So nothing special. So you have to remember only this proportionality thing. So please my dear students, don't try to remember this complete formula. ये complete formula नहीं remember करना है, just you have to remember this one. So it's very very important, and as I told you, already asked GATE 2022 just few years ago. So very important. If they can ask this case, then definitely they can ask this case too. ये भी पूछ सकते हैं, उसी का आगे बढ़ा हुआ रूप है ना. And you had seen previous how large that derivation was. कितना लंबा डेरिवेशन था, बट दे आस्क्ड just from that conclusion part. So you have to remember just proportional to r and proportional to r square, or r1 square minus r2 square. See, rs not this one, complete sublimation took 200 hour. Then for same material, and one more thing, same material thing, because you are not changing their respective diffusivity, so they are not going to change the material. If in first case naphthalene, second case also naphthalene. If they're not giving naphthalene, both cases different solid, then you have to use complete formula, and that will be very lengthy question. 0% chances that can be asked in your examination. 0%. ऐसा क्वेश्चन नहीं पूछेगा गेट में भाई, बहुत लेंदी हो गया, पूरा फॉर्मूला लिखना पड़ेगा. Can't ask. PBLM for both cases calculation, how large numerical you can feel. Okay, so if the radius is 15 centimeter instead of 10, how much time required for complete sublimation? Just use proportionality, you will get 450 hour. Very easy, very easy. बोलो बेटा, सभी को clear? Everyone crystal clear? So again I am telling you, my dear students, that this not important, no need to remember, and this is very important. Okay, केवल ये आपको याद करना है. ओके देखो कितना आसान है ना, ये इतना बड़ा टॉपिक था. हाउ लार्ज दिस टॉपिक इज यार, एंड इन दिस होल टॉपिक यू हैव टू रिमेंबर जस्ट W इज प्रोपोर्शनल टू RS, T इज प्रोपोर्शनल टू RS स्क्वायर, और T इज प्रोपोर्शनल टू RS स्क्वायर माइनस RS टेस्ट स्क्वायर. टॉपिक खत्म रे भाई, कितना आसान है, इतना बड़ा टॉपिक. हाउ स्मॉल दिस टॉपिक इज यार. सो आई होप एवरीवन एबल टू सॉल्व न्यूमेरिकल रिलेटिंग दिस टॉपिक. बोलो सभी लोग लगा लोगे ना? Now tell me, everyone enjoying lecture? सभी को मजा आ रहा है ना? Can we proceed? आगे बढ़ा जाए क्या बेटा? बोलो जल्दी बोलो, बोलो बेटा. Everyone enjoying in this crash course? समझ में आ रहा है कि सर ने कितना beautifully designed, how beautifully I designed this crash course, so that I can deal all topics with feeling in very less time, very less time यार. Okay, with 100% efficiency. Clear? Very good. Now see numerical. Oh, GATE 2022. Oh my God. GATE 2022 numericals. See, they had given that if two stationary spherical pure water droplets of diameter d1 and 2d1, CO2 diffuses into droplets from the surrounding. उल्टा दे दिया कि बाहर से सराउंडिंग में आ रहा है भाई. If the rate of diffusion of CO2 into smaller droplet is this one, then rate of diffusion into larger droplet is. How easy this is beta? Very easy. Because proportionality, then 2 W1 is the right answer. If dia double, rate double. Very easy na? Very easy. Just they asked based upon conclusion. Derivation was very large ना. देखा derivation कितना लंबा था, अभी शो किया ना आपको कितना लंबा derivation था, but still they can ask. So आपको derivation नहीं, ऐसे questions के लिए आपको final result का conclusion याद होना चाहिए. You must remember the conclusion. What conclusion you got from their respective complete derivation. Okay? Yeah, very easy. Now see next one. One more problem here given by me, and that is just a problem relating B stagnant case, but here the thing that I used is the dilute case. I'm giving assumed dilute case. So I told you for dilute case you can use P by PBLM as 1. So very easy question, very easy question. P1 will be PA set and PA2 will be 0, as I told you earlier. Okay, so this again is very formula based problem, very easy question. You have to solve again, because how you are going to calculate with the help of calci, that is very important for you कि आप calci से सही आंसर पाते हो कि नहीं. Okay, now next topic, general ranges of diffusivities. Problem already asked in GATE. So these general values beta, please write along with me, as already these all green slides I am dealing with you. Already सब कुछ पूरी slide नहीं लिया है हमने. So directly you have to write and you have to remember it. These are general values. In examination beta, don't forget to see unit. This 10 raised to power minus 5 in meter square per second. If you want to write centimeter square per second, then 1 meter equals to 100 centimeter. So meter square, so 10 raised to power 4 centimeter square per second. Then in centimeter, it will be 10 raised to power minus 1 centimeter square per second. So please check in examination in which unit they are asking. वो किस यूनिट में पूछ रहे हैं, आप मीटर स्क्वायर में याद करके जा रहे हो. You are remembering in meter square per second, but in examination don't forget to see in which unit they are asking. वो किस यूनिट में पूछ रहे हैं, इसे नोट करो फटाक से, फिर आगे समझाते हैं. Sir, can you repeat why PA2 you take 0 usually? Tell you better. Just wait. बेटा जब आप ऐसा कोई केस लेते हो, when you're taking this case, B is coming, going in this direction. A is diffusing here. As soon as A reaches here, immediately swept by this B, and now again fresh B here, so only B here. So जैसे ही A यहाँ पहुंचता है, B उसको भगा ले जा रहा है, क्योंकि B यहाँ पे चल रहा है, B यहाँ पे बह रहा है, बहाव में है, ड्राफ्ट है इसमें. Okay, so that's why here PA2 every time you can use nearly 0. If not given, just use 0. If given, then you have to use that value, but 99.9999 cases they are not going to provide value. That means it's 0, nearly 0. Okay, Rakesh beta, is it clear beta? Rakesh, is it crystal clear, my dear student? Rakesh, yes sir. Okay, very good. So for gases, clearly the diffusivity of gases largest, liquid little bit small, solid smallest. Power is -1. So 10 raised to power minus 5. Here 10 raised to power minus 10 to 10 raised to power minus 9. Range for solid 10 raised to power minus 13 to 10 raised to power minus 10 meters square per second. Maybe in examination they are asking gas to liquid value, diffusivity. So for gas 10 raised to power minus 5. For liquid 10 raised to minus 10 to 10 raised to power minus 9. So the range will be 10 raised to power 5 to 4. Maybe in examination they are asking reciprocal liquid to gas. Then it is 10 raised to power minus 5 to minus 4. So please see, they are asking the ratio of diffusivity of gases to liquid or liquid to gas. And these things, please don't try to remember. Just remember these three. ये तीनों का तीनों आपको remember करना पड़ेगा, because these are general ranges and already asked. PYQs already asked. ये पूछा हुआ क्वेश्चन है. Just if you know this range, you can give. So please, my dear students, these ranges immediately remember. आपको ये तुरंत का तुरंत remember कर लेना है. For every GATE examination, it is very, very important for you, बेटा. बहुत important है. Most important, guys. Okay. Now, next topic, empirical equations for measurement of diffusivities. For gases, for liquid. Generally, the names are not important in GATE examination, but in PSUs, they are asking names too. नाम भी पूछते हैं. But in GATE examination, 1% chances are there that they can ask name. Because just a few years ago, they asked about condensation theory was given by who? Answer was Nusselt in GATE examination. So if already asked, so you can tell that 1 to 10%, nearby 10% you can say. Chances are there. So Chapman and Skog equation and Gilliland's equation, these are the famous equations that you are going to use in order to calculate diffusivity of gases. They are empirical in nature. What is the meaning of empirical? Don't try to write complete equation, beta. पूरा equation लिखना नहीं है. Okay. In detailed course, I told about P and these all terms. What is this? For interview purpose, for GATE examination, that is not important. Okay, that for not important. So equation is also not important. So just name important, and now this conclusion important. So you have to remember this conclusion. Please remember it and please write it. Okay, write topic, Write name according to Chapman-Enskog equation or Gilland's equation. DAB is proportional to T raised to power 1.5 by P. Only for gas. This is for gas. So you have to remember this. Please everyone write it and then write done in comment section beta. फटाफट लिख लो. पूरा equation please मत लिखना. From both equation you can see the same relation is coming. Okay, same relation is coming. So please don't write this complete equation. पूरा equation मत लिखना बेटा. Please don't write this complete equation. ये नहीं लिखना है. जो लिखेगा नुकसान करेगा. Please don't write. Please don't write. Okay, just write name and this conclusion and write done in comment section beta. Already asked numeric PYQs based upon this topic also. So DAB is proportional to T raised to power 1.5 by P. And every year in many PSUs this already asked. In this year also asked. Done? Just write done in comment section. जैसे लिख लो फटाक से done लिख दो so that we can move forward बेटा. According to Chapman-Enskog equation and Gilland's equation, dVA is proportional to T raised to power 1.5 by P. That's it. इतना ही लिखना है. For gases. For gases. Done? चल बहुत अच्छी बात है. So clearly here you have to remember this. ये आपको remember करना है. Remember it. And names. Only remember names. ये नाम ही केवल आपको याद रखना है. No need to remember equations, complete equation. Now the next is this conclusion already given by me. And for numericals, TAB2 by DAB1 you can write like this: T2 by T1 raised to power 1.5. And because here P is present in denominator, so P1 by P2. And one beautiful, see problem number 18. See this problem number 18. Universal type problem again. They will provide one thing, they can ask directly this relation. Which one of the following is correct? In one option, it will be given for guesses. Just write. Second, they can ask numerical. So they will give you DAB1 is itna at this temperature and this pressure. Then they will ask what is the value of DAB2 if we are changing temperature to this and pressure to this. Put in this equation, you will get value. Okay, tell me everyone, crystal clear? Can we proceed? Just write CC in comment section बेटा. अगर एक कंक्लूजन सभी को क्लियर है सो केवल क्रिस्टल क्लियर लिख दो सो दैट वी कैन मूव फॉरवर्ड. आसान है, बहुत आसान है, वेरी इजी. ओके, नाउ नेक्स्ट इज एम्पिरिकल इक्वेशंस फॉर मेजरमेंट ऑफ डिफ्यूजिविटी ऑफ लिक्विड. हियर two equations are present. One Wilke-Chang equation and one is Stokes-Einstein equation. Name is less important for GATE examination, but most important for PSU examination. PSU examination में name बहुत पूछता है name. Okay, so here you can see this is beautiful equation and Stokes-Einstein this equation. Now clearly one thing is common in these two, that is DAB is proportional to this T by mu. This T by mu. This term less important, or you can say not important. They are not going to ask this. ये नहीं पूछेंगे. Okay, because DAB proportional, see here also T by mu. Viscosity and temperature. T by mu. So the only thing that you have to write on your notebook is DAB is proportional to T by mu for liquids. Okay, so you have to remember not this one, not this one. You have to remember this. Okay, and names only, not complete equation, नेम्स ओनली. और बहुत याद मत करना, अपने आप ABCD ऑप्शन में आए तो पकड़ सको, ऐसा केवल रहे आपके लिए. एंड नॉट इम्पॉर्टेंट फॉरगेट, अगेन आई एम टेलिंग यू, दिस इज इम्पॉर्टेंट वन, दिस इज इम्पॉर्टेंट वन, एंड दिस इज लेस इम्पॉर्टेंट, लेस इम्पॉर्टेंट, वेरी लेस इम्पॉर्टेंट, एक्चुअली वेरी लेस इम्पॉर्टेंट, एंड दिस इज वेरी इम्पॉर्टेंट. वेरी लेस एंड वेरी. ओके, क्लियर. अगेन I hope this topic is also crystal clear. Can we proceed towards next topic बेटा? यहाँ तक सभी को क्लियर है क्या? क्या हम अगले टॉपिक की तरफ चल सकते हैं? Crystal clear to all of you? Okay, so now I'm giving you approximately 30-second revision break. Just revise it and then write again CC in comment section. Or write yes sir in comment section. Yes sir means just in short YS. Yes sir in comment section. Then we will move forward. अभी तक जो भी चीजें हैं एक बार पन्नों को पलट के देख लो, सब क्लियर है सभी को? Everything is crystal clear till now. We can move. क्या हम आगे बढ़ सकते हैं? फटाफट देख के बताओ. आसान लग रहा है ना? इजी. Just write YS in comment section, everyone. चलो, बहुत अच्छी बात है. Okay beta, very good, all clear. So our next topic is diffusivity measurement and numericals. In a previous case, name was less important, actually very less important. But for this topic, name is most important. Which method you are going to use for diffusivity of gases or for diffusivity of liquid? This is very, very important. Name is very, very important for interviews as well as for gate examination. So this is the classification: diffusivity measurement and prediction. Measurement of diffusivity of gases, twin bulb method, Stephen tube method, and then empirical correlations are also there that just you had seen for gases. This already you covered. Okay, measurement of diffusivity in liquids, diaphragm shell method, and empirical relations already completed. So now that means three topics. Again we have to see what is twin bulb method, what is the Stephen tube method, and what is diaphragm cell method. And also we have to check what type of numericals that can be asked in a gate examination, because just you had seen one very, very large derivation was there, and just they asked if you know W is proportional to RS, you will be able to give answer. अभी तुरंत आपने देखा इतना लंबा डेरिवेशन था, उसमें केवल अगर आपको W proportional to RS पता है तो आप एग्जाम में लगा सकते हो. तो यहाँ भी कंप्लीट डेरिवेशन से क्वेश्चन नहीं आएगा आपका मोस्टली. सो वो प्रोपोर्शनलिटी वाला कौन सा पार्ट है जो इंपॉर्टेंट है इन सारे में? What proportionality part is the important part in these three topics: twin bulb, Stephen tube, and diaphragm cell method. They can also ask in examination what is a Stephen tube, क्या होता है Stephen tube, or they can ask which of the following method is used for the measurement of diffusivity of gases. In one option maybe Stephen tube method is there, and maybe if MSQ is there, then they will give twin bulb and Stephen tube both in that option. Diaphragm shell may also be there, but that is for liquid, that is not for gases. So you have to take only twin bulb and Stephen tube if they are asking about gases. बोलो सभी को क्लियर है क्या? लिख लिया ये, आगे बढ़े हम लोग। कैन वी प्रोसीड माय डियर स्टूडेंट्स? कैन वी प्रोसीड बेटा? Now, what is the basic for these all, beta? Actually, twin bulb method is based upon equimolar. That is based upon equimolar counter current diffusion. This is the basic principle on which you are going to do calculation. Stephen tube method uses B stagnant technique. B stagnant technique. Diaphragm cell method uses, थोड़ा छोटा लिख रहे हैं बट बोल रहे हैं ना, उससे समझ लो यार अगर नहीं दिख रहा तो. Diaphragm cell method, equimolar counter current diffusion. These are the bases. These are the base on which you are going to predict or you are going to calculate diffusivity for respective case. समझ में आ रहा है सभी को? In twin bulb method, two bulbs will be present, may be of same volume or may be of different volume. ये V1 और V2 सेम भी हो सकता है, different भी हो सकता है. In Stephen tube, the same thing that you had seen. This is the Stephen tube method. Here the liquid will be present. Suppose it's A, its diffusivity you want to check in this B. In diaphragm cell method, two chambers will be present. One diaphragm will be here. Similar to this twin bulb method. Similar to this twin bulb method that you can see here. Three cases. Twin bulb method, Stephen tube method, diaphragm cell method. Now, see twin bulb method. One by one. See twin bulb method. Just try to understand their basics, and this is their respective final equation. I will tell you what type of problems that can be asked in examination, because again this derivation is little bit larger one. ये थोड़ा लंबा derivation है, so directly ऐसा problem भी पूछ सकता है, but out of these all here I am writing less important for this problem 19 only. 1 से 18 तक सारा important था, ये 19 नंबर लेस इंपॉर्टेंट है थोड़ा सा, ये लेस इंपॉर्टेंट है थोड़ा सा, ठीक है. देन स्टीफन ट्यूब मेथड में आपका ये आएगा, और देन अगेन स्टीफन ट्यूब मेथड का ये वाला थोड़ा सा लेस इंपॉर्टेंट है, लेस इंपॉर्टेंट. if I'm writing less important, that means only you have to solve these numericals if 9 months is at least 9 months left for examination. If 2 or 3 months, then please don't try to solve if I am mentioning less important to any problem. I am writing there less important because maybe few students are going to see this lecture after few months after examination. Then they have to solve this if they have 9 months left for examination. Okay, because this is not a crash, just crash course. This is complete come crash course. So one students only by seeing this mass transfer will be able to get complete marks in mass transfer operation in upcoming GATE examinations. Okay, डिटेल वाला नहीं देखता, ये देख लेता है ना, हो जाएगा उसका भला. इसलिए ये हमने यहाँ लगा तो दिया है, बट अगर इफ ओनली 2 or 3 months लेफ्ट, देन प्लीज ये कंप्लीट वाला मत लगाना. नाउ व्हाट इज इंपॉर्टेंट हियर, सी डायफ्राम सेल मेथड, this numerical is important, 21 number. This is important one. This is important. Okay, similarly this is also important. So these two are important one. But this one is sorry, this comes under category of less important. 22 number less important. If I'm writing less important, that means can be asked, but chances are very low, very low. That's why I'm not recommending. If only 2 or 3 months left, then don't try to remember this complete formula. The only thing that you have to remember, just I want to show you beta, in all these three cases, पूरा मत लिखना कॉपी में, Assumptions are very easy, like negligible capillary volume, the capillary from which you are connecting these two bulbs, each bulb always of uniform concentration, pure A, pure B you are taking, temperature constant, volume of bulb constant. So that just general assumption. Please don't write in green slides. Copy में मत लिखना ये सब, ठीक है? Just write twin bulb method और क्या याद करना है? See, cumular counter current diffusion. So A must equal to B, transfer, but in different direction. So this is the basic, and by using this basic, you will get this equation. Now the thing that is important here, beta, the thing that is important here, that DAB is coming here inversely proportional to this time t. This is inversely proportional to this time t. This is the important part. This is the important part here. Okay, this is the important part. And if they are writing this, they will tell you that V1, V2, these two terms will remain same in both cases. Two cases they will provide you. So same in two given cases. दो केसेस होंगे जिसमें वो कहेगा वॉल्यूम में चेंज नहीं आ रहा है. ओके, दे विल टेल यू वॉल्यूम इज नॉट चेंजिंग एट ऑल. ओके, I hope everyone able to understand. Now two types of gases they will provide you, and then they will tell you from same initial partial pressure to some final partial pressure. If you want to obtain, if you want to obtain, then if in case one this time required and this time is going to give you this diffusivity, then in if second case the time is twice or like this, then what is the value of new diffusivity? Just you need this equation to solve it. Two cases they will provide, and they will tell you from same PA1 to PA2, and for second case some PA-1 to PA-2, and they will tell you that PA1 minus PA2 is equals to PA1 dash minus PA2 dash, or maybe P1 equals to PA1 dash. Two types of cases may be given, and they will also tell that PT is same in both cases. So again, as I told you, when large equation, large derivation is there, and the equation is not looks like something like standard form that easily we can remember, then they can ask proportionality type problem. Yeah, so पूरा याद मत करना, please. Okay, just remember this and see see how beautiful things are here. This is based upon complete, that's why I'm writing less important. Don't practice this, because I'm just less than 3 months left for examination. And here also see the beautiful thing here, DAB here also same thing, same thing. So that means just by remembering one you will be able to remember this. But again two cases they will provide, and from same initial to final level they will provide you for same values of respective partial pressures of A or B, for same value of molecular weight of A. This is the final equation. But one more thing that can be asked here, that is little bit rare one, that is TF then molecular weight of A. This is little bit, still it is important, but this is most important, because you are getting in case 1, in case 2 same to same equation, proportionality equation. Statement will be different, but conclusion that you need to remember is same. DAB is proportional to 1 by TF. So for liquid, some liquid 1, if all things are given, and now for liquid 2, if you are telling all things are still remain same as given in previous case, then if first case the time required for this 2 decrease is 5 minutes, and for second one time required is 10 minutes, then in first case is the diffusivity is 2 into 10 raised to power minus 2, then what is the value of diffusivity for case number 2? Proportionality type question. Tell me, is it crystal clear, beta? बोथ केसेस आर क्लियर ना? सो ये पूरा फॉर्मूला याद नहीं करना है प्लीज, जस्ट रिमेंबर दिस बेटा, or it is very easy to remember because clearly you had seen previous one and this one. Proportionality thing is same, proportionality thing आपका same है. Okay, done, clear. Okay, max to max, here also you can write about its respective row A, max to max if you want to write. Okay, done. No, but Shyan Mukherjee, still 2 plus month is there, so I'm not recommending to see this complete equation. Okay, this is important one, at least 100 times important. This complete equation is 100 times more important than this one. Okay, and this one actually same equation that you had seen previously, pseudo case. So if they are asking, then you have to solve from pseudo one. Now, a Stephen tube is a T tube over the top of which gas A flows, at the bottom of which a pool of volatile liquid, pool means रुका हुआ, stagnant pool of volatile liquid that is maintained at some constant temperature. The liquid in the pool evaporates, diffuses through the gas above, carried away by the gas. One then measures the fall in the level of the liquid in the tube. The tube conventionally has a narrow diameter in order to suppress convection. मतलब ये ट्यूब जो होता है बहुत पतले डायमीटर का लेते हैं कन्वेक्टिव करेंट्स को यहाँ पे, ताकि हम सप्रेस कर सकें, उसे ना कैलकुलेशन में लेना पड़े. Okay, these are assumptions actually not important, just here I added. I will give in PDF files, but no need to read it. Okay, normal things are given. Now in diaphragm cell method, one diaphragm is present, and again here the thing that you need to remember, only and only, see, it's a final equation. Where is it? Derivation is large. See, derivation is very large. So see, this is the final equation, and again here you can see beta, these all are known as, this complete term is known as Sells constant, alpha. So only the thing that you have to remember here that DAB for this case, the thing that you need to remember, केवल आपको जो पूरा max to max remember करना है, यहाँ हम लिख देते हैं DAB is proportional to 1 by alpha TF. This you need to remember. ओके, दिस यू नीड टू रिमेंबर, केवल आपको ये रिमेंबर करना है फिलहाल के लिए. दिस यू हैव टू रिमेंबर. ओके, यू नीड टू रिमेंबर इट. नाउ this one is less important, but it is a little bit you can say twice important as you had seen previous two cases, because this looks like little bit standard form and easy equation to remember. So if they are going to ask, they are not going to ask in this manner. वो इस तरह से लंबा नहीं पूछेंगे, वो सेल कांस्टेंट की वैल्यू देंगे. They are going to provide you cell's constant value. Okay, and maybe they can ask you the unit of this cell constant. So this also you have to remember. And this already asked in PSU examination, the unit of cell constant. That is 1 by meter square, meter raised to power minus 2. Very easy to remember. So please don't remember this complete. ये पूरा मत remember करना यार. And in your notebook, just write the thing that here I am writing, this one and this one, these two things. Okay, here just I am giving this complete derivation. यहाँ ये complete derivation इसलिए लगा दिया ताकि आप देख के समझ जाओ, ये बहुत लंबा है, ये इतना लंबा, ये स्टैंडर्ड फॉर्म में अगर नहीं है तो they can't ask complete. They can ask you just this proportionality thing. So just you have to remember this one. And in all these three, one thing is common, DAB is proportional to 1 by TF. That is the most beautiful thing everywhere. Okay, and these you can also feel with NA by A equals to DAB by RTZ, PA1 minus PA2. DAB and NA, what is NA? Mole per second. Okay, so by time, mole per unit time. So from there you can also see this DAB is proportional to 1 by T. So this is universal truth here. So that's why I am giving more and more weightage towards this 1 by TF part. ये 1 by TF वाला बहुत इंपॉर्टेंट है यार, क्योंकि सब में आ रहा है 1/TF 1/TF 1/TF। एंड ऑल्सो यू कैन सी फ्रॉम योर मेन इक्वेशन, अगर कोई टॉपिक नहीं भी देखा तो मेन इक्वेशन से भी फंडामेंटल दिमाग लगा के देख सकता है। बट one extra thing is here, that is cell constant in this case, and in previous case it was this rho by m, rho by m part. hmm? Now see universal numerical number 21, how they are going to ask problem in examination. They will tell you two cases are there. In one case A and C mixture, in second case B and C mixture. They will tell you same type, size and shape used for diaphragm shell. Same diaphragm shell used for the measurement of diffusivity of A in C and B in C. A in C and B in C. Same diaphragm यूज किया गया है A की डिफ्यूजिविटी C में मेजर करने के लिए और B की डिफ्यूजिविटी भी C में मेजर करने के लिए। क्लियर बेटा? और फिर कहेंगे वो कि CA1 से CA2, आप जिस जो यहां जा रहे हो वो CB1 से CB2, ये दोनों सेम है, ये दोनों सेम है। CA1 CA2, CA1 equals to CB1 not and CB2 equals to CB2 not. Yeah, these are same. This is same. This is same in both cases. They will give you these things, and then they will tell you if after time t1, like they will give you 2 hour, you will get this, and here after 4 hour you will get this. Then they will ask you what is the diffusion of A in C. What is the diffusion of A in C? Oh, sorry, B in C. They will provide A in C, and they will ask B in C. So with the help of proportionality, you know this. You know this proportionality type question. Directly see how easy it is. And this is for all cases very important beta, because it is very easier, very easy to remember. Derivation are very large, but the conclusion is very easy. That's why I told you, please don't forget this. Just fundamental. एंड ऑल्सो प्लीज डोंट, डर मत जाना बहुत लंबा डेटा देख कर, देखना डेटा में आखिर पूछा क्या है, इसका क्वेश्चन बहुत बड़ा बनेगा। द क्वेश्चन, if one first instant you are going to see it looks very large, but after reading you will see, oh, the solution is just one line यार। इसके स्टेटमेंट बहुत लंबे बनते हैं लेकिन सॉल्यूशन बहुत छोटा होता है। गेट में से बहुत क्वेश्चन पूछे गए हैं, मेनी प्रॉब्लम्स ऑलरेडी आस्क्ड इन गेट एग्जामिनेशन लाइक दिस। स्टेटमेंट वेरी बिग, सॉल्यूशन वेरी स्मॉल। बोलो सभी को क्लियर है क्या? This universal numerical number 21, is it clear to all of you? In similar manner they can also give you for diaphragms Stephen tube method and twin bulb method, उसके लिए भी आपको ऐसा ही दे सकता है। Is it clear to all of you बेटा? बोलो फटाफट बोल दो सभी को, क्लियर है क्या ये? चल बहुत अच्छी बात है। Now 22 number not important for this time if you are preparing for this upcoming gate examination, that is less than 3 months left, so please, nearby 2+ month left, so please don't see this one, इसे देखने की requirement अभी नहीं है। Okay, but this can also be asked. This is less important, but it is little bit extra important in compared to Stephen tube and twin bulb, because here formula is little bit smaller one. Yeah, formula is smaller in terms of cell constant. Okay, but this time please don't see this. If I'm writing anywhere less important, then that numerical you are not going to practice if time is less. If time is less than 6 months when you are seeing this course, then please don't solve. Now one note is there, what is Winkelmann diffusion? Just a theory I added here because asked in PSU PYQ. What is Winkelmann's diffusion? You had seen that Stephen tube na, that Stephen tube diffusion in that case is known as Winkelmann's diffusion. In short, it's very easy. This is the Winkelmann's diffusion. When a liquid is allowed to evaporate in a narrow vertical tube and a steady state temperature is maintained, mass transfer takes place from the surface by molecular diffusion alone. This is the technique developed by Winkelmann to determine the diffusivity of the vapor of a volatile liquid. So, narrow tube. This tube must be narrow one in order to suppress convection currents. So this is what, this is also known as Winkelmann diffusion, because this technique was developed by Winkelmann. So just name is important, and narrows what is Winkelmann diffusion, very very easy. ओके, डन। बोलो, सभी को क्लियर है क्या? हम्म। कैन वी प्रोसीड बेटा? जस्ट कंफर्म मी माय डियर स्टूडेंट्स, कैन वी प्रोसीड? डन। And lecture is already nearby 2 hours, so just few more topics I will discuss today. Okay, very good. So next is a multi-component diffusion and numericals, and this will be today's final topic here. आज ये हमारा final topic होगा, and after that I will end this lecture. Okay. Now, sir, multi-component diffusion is present in our syllabus. Yeah, but it is present, and only one part, the most important part that can be asked, and already asked, you can see in PYQs from multi-component diffusion. That was relating diffusivity. How to calculate diffusivity? Asked. I will show that numerical to you. It was between 1990s to 2000. Okay. So multi-component diffusion. Now, very very easy. First, try to understand this case. We already learned. हमने already पढ़ा है अभी. If we have binary mixture of A and B, अगर हमारे पास A और B का binary mixture है तो what was general equation of diffusion, or we can say mother equation? That was Na by A and Ya by A minus Dab dCa by dZ. This Ya can be written as Ca by C. And you had seen this n was nothing but Na plus Nb. If two components are there, that was summation of Ni at I equals to 1 to n. जितने भी component है उसका sum कर दो बस, सबका mass flow rate का. You are going to add them. So this n is summation of this. Like here, just two components are there. If more than two components, no need to worry. This equation now, see, converted like this. Instead of A, you are writing for some ith component. Now summation of all ith component, like Na plus Nb plus Nc plus Nd plus Nd, you have to write all components. Now here D, A in B, na. So here you are writing I. So I where in some mixture, na. You are going to calculate it. So here instead of DAB, you have to write DI mix. And all other things will remain same. So the one thing that can be asked in examination, the equation. So very very easy to write their equation. And this is less important. The most important thing that already asked, जो already पूछा हुआ है, that is the calculation of this DI mix. This is the most important part. This is the most important part. Already asked in GATE examination. ये already पूछा हुआ है GATE examination में. And you have to calculate it, because A in B, if diffusivity is given, and if you want to calculate A in some mixture of B, C, D, my dear student, these two values are not the same. These two values are not same. So you have to calculate what is the value of DMX. What is the value of DMX? Like here, if ABC in this proportion, here ABC in this proportion, if A is going from here to this side, then what is the value of Na mix? And for that Na mix, what is the value of Da mix here? So you have to calculate Da mix. They will provide in examination what is the value of DAB or what is the value of DAC, etc. And they will ask you what is the value of this DMX. DMX. So problem statement is clear to all of you, beta. What you are going to see here, ये क्या आप सभी को clear है? फटाफट बता दो यार. Everyone just confirm me, beta. What thing you have to calculate here? Is it crystal clear? Very very easy topic है, बहुत ही आसान topic है यार, बहुत आसान है. Yes, sir. Very good. So now see the formula for DI mix. This is the formula. How to calculate DI mix. You have to remember it. Please remember it. आपको इसे remember करना होगा. You have to remember it. Important है. If I'm writing anywhere, remember it, then you have to remember it. You have to remember it. Di mix is equals to 1 minus yi upon summation of j equals to 1 to n, but j is not equal to I. If you are writing a mix, that means here you no need to write ya or da. Okay, daa. How, sir? This little bit confusing one. So it is much better to remember this one like this. After remembering it, practice to write the below equation. Like if some binary mixture is there here, ABC, and they are asking DA mix. So DI, so 1 minus YI, here A, so 1 minus YA. Now here YJ, it's not I, it's J. That means you can't write I here. J is not equal to I. See, I'm not writing YA here. I'm writing just B and B here. And you are calculating for A. So A will be present, A, see, D, I and then J. So I will be present in all, everywhere. So D, A. So A in B, A in C. It's very, very easy now. Now how to remember? How to remember it? See. See here. Suppose A, B, C given. And they will provide you D, A, B and they will provide you D, A, C. And they will ask you D, A mix. This they will ask you. So very easy. 1 DA mix is 1 minus A, so 1 minus YA. Now YA written, so please write here YB and please write here YC. Just like this, see here. YB, YC. Remaining you have to write here. And divide by plus here. So YB, so D, AB. YC, so D, AC. Very easy to remember. बोलो समझ गया क्या सभी को? ये याद करने का तरीका है क्लियर है सभी को? बोलो. Is it crystal clear to all of you बेटा? Like here if they are asking DB mix, so B, so 1 minus YB, B written, so here write YA, YC. Now B, so D, BA and D, BC. If you want to write DC mix, then 1 minus YC upon YC, so YA, YB. Because A here, first आप C के लिए लिख रहे हो, so DC, and here A, so C in A and C in B. Tell me बेटा, everyone able to remember or able to write it? ये फॉर्मूला लिख ले जाओगे ना सभी लोग? How to write it? Just little practice required. Don't try to remember this all. Try to write it. Try to write it. Okay? बोलो सभी को क्लियर? Everyone, just tell me beta. Everyone, please beta confirm me. Is it crystal clear? I'm writing remember it, but actually you have to practice. You have to practice to write. Practice to write. आपको ये प्रैक्टिस कर लेनी है केवल लिखने का तरीका. बोलो लिख ले जाओगे ना सभी लोग? एंड तक आते आते बच्चा लोग गायब होने लगता है, दिमाग पे प्रेशर ज्यादा लगने लगता है. यस, याद केवल लिखने का तरीका देख लेने का, जैसे पूछेगा खटाक से लिख के निकाल देने का. और एक गेट पीवाई की पूछा भी हुआ है बेटा, सो इम्पोर्टेंट. See one problem here given, CO2 and N2 given, CO2 and S2 given, N2 S2 given, but here asking CO2 mix. So for CO2 mix no need to use this data. इस डेटा का यहाँ कोई यूज ही नहीं है, इसका कोई यूज ही नहीं है. ये डेटा और ये डेटा ही आपको इस्तेमाल करना है. So extra data provided by me. Formula based question. So DCO2 mix means 1 minus, please write this equation here. ये जरा CO2 के फॉर्म, S2 के फॉर्म में लिखो, N2 के फॉर्म में. Please write this complete equation and then write done. Then I will write ये complete equation. After writing just formula based you have to put values here. आपको केवल values put कर देना है. Okay. And one more thing beta, here two location partial pressure given. Don't worry, यहाँ का लें कि किसी दूसरे लोकेशन का लें ऐसा नहीं सोचने का. किसी भी लोकेशन का लोगे रेस्पेक्टिव वैल्यू सेम आनी है. डिफ्यूजिटी थोड़ा ना बदल जाएगी. आप इसको प्रूव भी कर सकते हो, प्रूव भी कराएं. So they will provide you two locations partial pressure. So don't worry, you have to choose any one location for all partial pressures, for all mole fraction calculation. Any one location you have to choose. कोई एक location आप choose करोगे, either this one or this one, any one location. By any location you will get final answer same to same, 100% same. Just write done in comment section after writing it. एक बार done लिख दोगे इसको जैसे ही लिख लोगे. Just write done in comment section बेटा. Come on everyone. इक्वेशन लिख लिया इसका. The problem on which I mentioned less important, please don't practice in these last few months. Done. Just write done in comment section beta Rakesh and everyone. Now just compare with me. Done. Very good. So 1 minus, because CO2 here, so why CO2 upon. Now some students forget in examination that y by d here or d by y. Beta, if here you are writing by mistake d by y, then y will come here and the C, the unit is not consistent. 1 by d is coming. So automatically you will get, no, here it is not d by y, it's y by d. So y by d means, now y after CO2, the next two components nitrogen, hydrogen. So y N2 plus y H2. Now divide. CO2 mixture. So D CO2, D CO2. CO2 where? In N2. CO2 where? In H2. This is the formula. I hope everyone crystal clear यार. बोलो समझ गया ना? समझ में आ गया? Now just formula based, and here all things are in meter square per second, so don't be in hurry. In centimeter square per second. So don't do this silly mistake. ये silly mistake मत करना. Okay? Now this is the solution here. Very very easy. So you have to calculate this also. आपको ही निकालना होगा. See, location 1 लें या location 2 लें, फर्क नहीं पड़ता. See, by one location, the answer is coming this. And if I'm choosing the second location, the answer is coming this. Both answer are 100% same. Okay, so any one you can choose, either this or this. Or answer will remain same. Answer will remain same. Same answer every time. Same answer every time. Because diffusivity is not going to vary with length. Huh? Clear to all of you बेटा? चलो तो आज यहीं पे रहने देते हैं. इससे ज़्यादा आप हजम नहीं कर पाओगे, इससे ज़्यादा पचा नहीं पाओगे. I think that's enough for this lecture. So at last, just I want to tell you one thing beta. If you want great rank like rank 1 to 100 for your dream job, then revision is the key for success. I must do my revision daily. 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 I must do my revision daily beta. All the best, take care, love you all, and a very very happy good night to all of you beta. Lecture PDF will be available in Gate Chemic Learning App. Don't forget to practice all problems again beta. See their respective solution only if unable to solve. Don't give too much time. Max to max try to solve any numericals 5 to 6 to 7 minute max. If unable to solve, immediately see solution and then solve again. Okay? ऐसा नहीं कि 1 घंटे तक लगाए पड़े हो, क्यों नहीं लग रहा, मैं सॉल्यूशन नहीं दूंगा. Don't take like this. 5 to 7 minute max. Unable to solve, then just see solution and try again. Take care, all the best, and a very very happy good night to all of you beta. Soon we will meet again in lecture number 3. In that lecture, we will finish this diffusion as well as mass transfer coefficient. Take care, beta. Please explain method for calculation of yn2 and yH2. Oh, wait. One query asked by one student. Wait, beta. See, in this beta, partial pressure is given. Okay, and the mole fraction of any component A is given as partial pressure of that component to total pressure. And this is what? This is Raoult's law. Okay, so at any location, suppose you are choosing this location, my dear student, so add all, you will get total pressure, then 140 by 100, it's 0.4. YCO2 is 0.4, YN2 is 0.5, YH2 is 0.1. Like here I want YN2, so YN2 is 0.5, YH2 is 0.1. And if I'm choosing, instead of this, I'm choosing this location, then yn2 is 75 by 100, that's 0.75. YH2 is 0.15. Is it clear beta Rakesh? बोले बेटा राकेश, क्या ये क्लियर है? No doubts now? Can we end this lecture beta? Chal, very good. Yes, thanks. You're welcome beta. Oh beta, take care once again. You're all welcome. Very very happy good night to all of you beta. Take care. Love you all.